Good evening, guys.
Good
Can you hear me?
evening.
Very good evening to all of you. How's the week? Okay. Right. So we have discussed the other day uh, comparing and revisioning. Right. So how to compare two drawings and get a report, and then how to print that report. And then we went on to discuss how the revisioning can be done. The difference between revisioning and comparing is, of course, in revisioning, we do update the quantities also, right? But it's a lengthy process, but still you can update your quantities based on your revision drawings one by one, right? So that is where we stop. Let me share the screen. And there was a question before I move into 3D measurements. Let me share the screen, and I'll come out from this. I'll show you the substructure one. Tusita asked me a good question. Let's go to the substructure here. Yeah. So when you do the revisioning, right, on foundation layout, you can see now your original drawing has been replaced with revision 1 drawing here. Rest is locked or frozen. And there's a question, can we, let's say, update, let's say, for example, we have done a mistake or we have forgotten some item and we need to add few things of the other drawings, right? Not concrete. Let's say superstructure concrete. Framework. Yeah, here. Yeah. Let's say you need to add something uh, that we have forgotten here under 250 um, cubic meters. And that was the question, right? And these are locked and you can't measure from this. Now, for example, let's say now, yeah, ground floor masonry, take masonry. Here also take masonry here. Yeah, wall type 1 or whatever. And if you want to add, let's say you have forgotten something here and you want to measure this one as wall type 1. I'm just measuring, okay? I know it's not wall type 1, but how do you do that now? Uh, you go to dimension and then take points, and then you can, now you should be able to measure now, right? From here to here, here to here, you should be able to measure because you have selected the point mode, but it's not getting selected now. Right? That was a question. Right. So what you need to do here before you have to add any quantities after revisioning, you need to click on this for the right click, and promote the drawing before you move. Promote the drawing means now you are ready to measure from that drawing also if you want to do further measurements. Right. So you promote the drawing and then you unlock the drawing here. Yeah. You can say for the new revision, keep the same drawing file and open. Just a second. Guys, can you hear me? Sushant?
Can. Yes.
Yeah, okay. I got a call saying that I can't be heard. I thought everyone has the same issue. Anyway, okay. So I was explaining. Okay, now I have promoted this drawing, and now I want to measure maybe a forgotten, let's say, wall. Now you can see this is now activated, right? Whether it is line mode or point mode. Now you can see it is 75 square meters. And if you have forgotten to add this one here, right? And you can see now it became 97. Now you can incorporate this. Understand? So even if you have to measure from first floor drawing, what you need to do is you have to right click and say promote drawing. Otherwise, CostX will not allow you to do any measurement, any changes to the original measurements. In other words, the dimensions, quantities, unless you promote the drawing after the revisioning process is done. You understand? Right? Can you try that before you proceed further? You open this project, the substructure project, and you did the revision in the other day before we start the 3D measurements. Can you open this? And then uh, these drawings are locked at the moment. You can unlock by right clicking and then say promote drawing. Okay. And then when you say promote drawing, it will ask you whether choose a new drawing or if you have, let's say, a revision drawing, you can do that. Let's say you have a revision drawing of first floor plan, then you can promote that drawing and do the revisioning process, or you can say keep the same drawing and proceed because we have forgotten to include few quantities. So now you can measure from these quantities and update the what do you call the dimension quantities. And then when you update the workbook, right? When you finish it, you upgrade the workbook and you can say recalculate the workbook. All the quantities will be automatically calculated. You can see here, all the quantities will be calculated. If you go to masonry, you will see type 1 has been increased now, automatic. Right? We didn't do any workbook related activity here, but the quantity has been automatically updated. And that is a part of reversioning. Okay, can you quickly do that before we proceed with the 3D measurements? I'll give 2 minutes. Take any drawing, okay? It could be level 1 frame here or level 2. If you are doing level 2, you have to select zone 2. Remember, you have to select zone 2. You need to be little vigilant, little mindful about where you measure and what folder and so on. Even you can select any window, for example. You can add any windows here if you want, or you can add, let's say, a wall type. But before that, you need to promote the drawing, promote the same drawing, not a revision. If you promote a revision drawing, what happens? The original drawing will be replaced. And then there's a process that you need to follow. That is the revisioning process. I hope you have followed the videos last week and then you got the workflow sorted out. Please let me know when you are done. Right, guys, are we okay? Right, so it's good. And it was your question, and others also got benefited. That's good. How about others? Sushan, Kadir, Nimasha, please drop me a message if you're done. Good. So after revisioning function here, right? Other drawings will be locked, or in other words, which are not revised will be kept locked. You can unlock by right clicking and doing the promotion. Right. When you say promoted, you can promote the same drawing so that you can measure from the same drawing again. Let's say if you have forgotten something, you need to add to the previous quantity, you can do that. So accordingly, the workbook also will be updated. Right. So can I go back to 3D building now? Right. So I close this and I open now the other building, which is the 3D. Yeah. So I open a building type called residential here, which is the 3D measurement. So this is what we have uploaded, the 3D, right? So we started looking at this 3D and then another one called Eco Home or Eco Home, right? So we went on to discuss various views, transparent, wireframe, right? And also when you select any element and click right click on that, you can get object properties. How do you hide objects? Now, for example, let's say now, okay, let me show you something else also. When you click on this 3D right click, the menu is different from when you right click outside sometimes, not here. You can see from here when you click on outside, because there's no outside because everything is the model. For example, let's see here. Yeah, you can see here. Sometimes it is different. Now, when in this case, if you want to remove, let's say if you want to see only the roof of this building, you can say, okay, you can say hide objects, right? You can say you can hide roof. Now you can see what is inside. So that is also available. If you want to have a clearer view from the top or from the bottom or from the side, you can hide objects and see the 3D model, right? Then you can say show all objects again. And then if you want, you practice with me, please. You can practice with me. If you take this one and say hide objects in all walls, for example, or external panels, let's say. Now you can see through the building. So I removed all the external walls now. Right? Not these external walls I have removed. So likewise, can do so many things from the 3D itself. Right, I'll put it back, okay? I'll say show all objects. And here also, if you take structural drawing here, and let's say show me without the slabs, for example. Okay, show me this, hide the top slab, for example. Let's say hide objects in floors or only concrete deck. Yeah, you can see. Right, so you can just take out the roof if you want. Right, you can just take out the roof if you want. So likewise, you can do so many manipulation here with the 3D. If you don't want to see the piles, you can do that. But I wanted to ask you one thing. Now, when we measure any 2D drawings, AutoCAD or PDF, our first step was to calibrate the drawing, correct? But I didn't do any calibration here in a 3D drawing. Actually, that is not required because this is always done 1-to-1 scale. 1 millimeter is always 1 millimeter in the model also. So there's no need of calibrating the 3D model. By default, you can just continue to measure the quantities from the 3D model. But if you want only, let's say, columns, for example, so what you do is you right click on that and say show only objects in all structural columns, right? And these are the columns that you have in the entire building of that type. But if you want to put it back, and you can say show all the objects. Right? Can you practice that? You can just take out the roof if you want, or you can take out the first floor if you want, right? Or you can take out all the floors if you want. You can say hide objects in floors. You see, all the floors I have taken out, and now only the beams and the columns. And if you want to see something very clearly in the model, you can do that, right? You can have different views, right? And then you can understand how the beams they have modeled, right? How the slabs they have modeled, right? So you can put it back. But can you do that? Can you practice that? Or if you want to see only the piles, you can do that. See, that is hide. You can say show only objects in structural foundation or pile. Show all objects. If you want to see only all structural foundations, you can see that, right? And you can see the pile foundation here. But can you practice that? And if you want to see the volume of one of the pile caps, you can go to object properties and you will have everything. It's 1.26296 cubic meters. Width is 1.8. Length is zero point 0.8 or 800 and 108, 1800. All the volume, everything is given. And the depth also here, 800 by 1008 by 900. Just give me a second. Okay. Now, let's say we have gotten this into this view. Now we want to find out the pile cap quantities, for example. Right? If you want to take only the pile caps, still you can do that. You select the pile caps, right? And you can say here, object properties, show only objects in pile cap. Here we go. Now let's say you want to find out the quantity of the pile caps. Okay. You want to quantify the pile caps only. So how do you do that? Are we going to measure like what we did in 2D drawing, right? Getting, creating dimension groups and then measuring the area multiplied by the thickness and all, and then you prepare the what do you call workbook. In 3D measurement, luckily we don't have to repeat on any of this, right? If the model is such that you can abstract information, you can produce your dimension groups accordingly. Now you have isolated what you want to measure. For example, let's say the pile caps. So there's a process. Okay, you need to follow me now. So we are slowly getting into 3D measurements now, right? So we have isolated what you want to measure, and then what you need to do is you have to go to dimensions and say you can automatically create the dimension groups, right? According to this, for example, let's say dimension import dimension using beam template. Some objects have been hidden. Data will only be imported for visible objects. Do you want to continue? I'll say yes. You see what happens now. It goes to kind of a dialog box here, and you have to select one of the file types. Here, you need to select the last one, beam import Revit general. Beam import Revit general. You select this and say open. I'll do it again, don't worry. And you can see what happens automatically. You didn't create any dimension groups. You have created dimension group automatically called structural foundation. So he has found, or he has formed a folder already, and within that you have pile caps, 87 cubic meters. You see, we didn't measure. That is the beauty of 3D measurement, right? You select one object and you can soon create the quantity, right? If you want to measure form work, that's a different thing. We know how to get the form work, right? Right, from this, when you create the workbook, right, then obviously you can manipulate the quantities, right? Can you quickly measure the volume of all the pile caps and create a dimension group? Of course, you don't create anything. So what you do is once you have selected these objects and you say dimension import, we haven't used this method or we haven't used this function before. When we did manual, what do you call dimension groups? Because in 2D, everything is manual, right? We have to create manual dimension groups, and then we could measure certain areas automatic. That's not a problem. So we had the opportunity to measure area, right? And then length, and then we can count and all these things in 2D. But in 3D, it's different ball game. Everything can be possible. You can abstract information from the model itself. And how do you do that? First, you need to create the dimension group. You can do it automatically. How? Dimension, go to import dimension you using beam template, and it goes to, okay, then it will ask, are you sure you want to go for the visible objects? I say yes. And then it goes to a kind of dialog box here, and you have to select this beam import Revit general .xslt file type. So you select that one and say open, and automatically the dimension groups or dimension group will be created because it's only one object we have selected here. If we have selected two objects, which I will show you now, there will be two dimension groups created automatically. If we have selected three objects, then there will be 3 automatic groups created already. So you understand what I'm going to do for the entire module, or entire 3D model. Okay. Okay. Have you got 87 now? And drop me a message. Everyone has got 87. I need you to respond to me. Right, Dushan? Good. How about others? And this is the interesting part of all these things, okay? We have been doing all 2D measurements and it takes time, but still it is very interesting, right? You can manipulate, you can count very fast, and then you can take the measurements, but you need to use your brain, right? You need to plan your measurement little better than what you normally do. So you need a bit of planning for the 2D measurements, but 3D measurements is nothing but using your functions here, right? Anyone is not able to do? Nikhil, Tusit, did you get 87 cubic meters here? First, you need to select the items. How do you select the item? So I'll do it again. Show all the objects, right? So what I did was, okay, so you select only the pile cap, right click and say show only objects in pile caps. Okay, pile caps. Oh, current selection. That is only one. If you take current selection, that is only one. And if you say you have to show all objects in, let's say, foundation, it will show pile cap and the pile in both. But if you only select piles, it will show you, sorry, only pile caps, it will show only the pile caps. Now, when you do that, right, now you have isolated pile caps from the 3D. So what you can do is dimensions, import dimensions using beam template. And it says certain objects are hidden. I said, okay. And then you have to select this last file, beam import Revit. You have to select that file type and then say open. And then automatically, uh, this dimension is created. And then, okay, now we have done this. So how do you put into the bill or workbook? How do you put into the bill? Now, normally you don't do that because you don't create a BOQ for each item, right? You will create a BOQ for the entire building or entire 3D model. But just to show you how we can even create the workbook automatically, right now, since you have done this one automatically, the dimension group, now you can prepare your workbook also automatic. How? Now you can see now workbook, add workbook. I don't go to that, and you can say generate workbook from dimension groups. This is 3D measurements or quantity harvesting. So I select this function here, generate workbook from dimension groups, because I have already generated some dimension groups. So I'm going to generate the workbook also automatically from the generated dimension groups. So I'll click on that and you see what happens. You give a name, say pile caps. Okay. I'll just give a pile cap. and you can see all zoning has been created. And if you whatever all the zones, I select all the zones here. When I select this double arrow, everything will come into this. Now, otherwise, you can pick and select like access level, first floor level, second level, RDS access level. These are the levels within the 3D model. So I'm not sure. I'll take everything I need. And then that's all. Everything is by default. And you say, okay. Now you can see automatically workbook has been created. Right? And this is level 1. If you can remember, this is level 1. If you double click on this, you can go to the measurement or the BOQ level. Right? If you double click on this quantity level, right? There's no double clicking here because it has a link now. Right? Because we don't have any manual what do you call TDS sheet or measurement sheet or level 3 here. Even if you click on this, it doesn't go anywhere because there's a calculation which has come, or there's a link which has come automatically from the dimension group. You can see 87, 88. This should have been 87 point something. Yeah, 87.48. So rounded up to 88. Now you can see this is the BOQ summary level and this is the BOQ itself. Now what is the what you need to do is you need to if you want to type a proper BOQ, you can just type, right? Because this is representing the dimension group here. So you can do some editing and make your BOQ here. Or you can export this one into your Excel and you can edit the quantity, the descriptions. Either way. But you can't do that in educational version. You can't export this one into Excel. But in commercial version, that is possible. Now, can you quickly prepare a workbook also for these pile caps? So how do you do that? You come to workbook tab and say add generate workbook from dimension groups. This one. Generate workbook from dimension group. And you can create the BOQ also automatically. Of course, you need to do a bit of editing if you want to have a very systematic, very formatted BOQ. You can do that. So 3D measurement is very fun. Everyone will like 3D measurements. Just let me know when you're done. So I have isolated one element from the drawing, which is pile cap, and I have created a dimension group from that. So quantities have been harvested, 87, and we have created a BOQ for that particular item. Normally we don't do that. For only single item, we don't create any BOQs, correct? But I just wanted to show you how you do that. We okay? Tusit, are we on the same page? Nimasha has done good. How about others? Darren, Kadir, Pitana, Nikhil, Nagarajan is here, Anisha, and Vinia. I hope everyone is catching up with me.
Yes, sir.
Good. Right, so can I move into next phase now? Now let's go to drawings again. So what I have done is from a given 3D model, you can isolate any item now. And if you want to find out the total quantity or maybe a quantity of a single element, you can do that. But that is manual, right? Then you can select and then you can generate the dimension group automatically using dimensions, import dimensions from the BIM template that you have selected. So what happens when this function works? It will extract the quantities from what is on the screen. So if you have selected the entire building, it will create all the dimension groups in that particular building. Now we are going to see that, right? So I'm going back to, so I'll delete this one, okay? I'll delete this one because I'm going to do a proper, going to do all the dimensions. I'll delete this one and I'm going back to the entire model, right? Now you can see here. Now let's say if someone wants to know the total volume of the columns, how do you do that now? Total volume of the column. You right click and say, so show all the objects in structural column. Everything, not only round columns, right? Everything, right? Not only round columns, structural columns, all. Okay, this is what we want, right? I'll say show all objects. Again, I'll do that. I click on that, show objects in, yeah, all round columns, right? We have only all round columns here. Let's say structural columns, fine. And if you want to find out the quantity of all this, right, columns, what you do is again, go to dimension, import dimension using BIM template and say, give me the quantity of the visible items and select this appropriate file here and say open. And you can see the system is generating the quantities automatically here. But in this case now, right, it takes only, okay, this column and this column and this column separately, you can see, right? If you take all the columns, you can see there are three types of column. One is 750 and the other one is 356, whatever, right? I think that those are square columns. So if you just double click on that, now you can see you have not created anything like that before, right? You did when you do it manually. It says structural columns, universal column, blah, blah, blah. Default displays length, measurement type also length. Now what we need is not length. We don't need in length, right? Columns, if you want, you need in volume. You need to see in volume. So you can change it and make it volume. And you can do for the others also. So you go there, double click and say, give me in volume because we are going to make a BOQ, not a cost plan. Sometimes cost plan you can even use the length, but here we are using volumes. And you can see that is being converted into volume. And here, and if you double click on that and say give me in length, no, sorry, give me in volume, it will give you in volume. Now you can see how quickly we can convert into cubic meters, though it is giving in linear meters. Here, why this 0 is, this is maybe lesser than, yeah, you can see it's 0.41 cubic meters. So that's why you get it as a 0. Otherwise, this is the quantity has been captured. If you want to go into details, you can go to dimension like what we did in two-dimension one. Same thing, okay? Same thing. You can go and check everything. And this is visible here. And when you check here, you can see it's visible. And you can change the, right? You can change the height also if you want, right? You can change the height if you want after that. But you don't normally do because you have abstracted these columns from the 3D. If you want to change the height, then it is not correct. But what I can say is you have the flexibility, do some manipulation if you want to do. Right. So can you take all the columns of that particular 3D model and quantify the quantity as 117? Can you quickly do that? Now, when you are in the 3D mode, you can see there's no line mode, there's no point mode selected. Automatically, there's an object here. So that is been selected already. I haven't done anything here, right? Because I didn't do anything manual. So automatically, you have line mode, point mode. That is mostly for the 2D, but you can still use, if you want to measure something from the 3D, you can still use the point mode. You can do that. But normally, uh, object mode is being selected by default. Anyway, nothing to think about it. Right, everybody has got the quantities here, 117 cubic meters. All good? Yeah, good. Tusit has got 117. How about others? You should be getting these 3 dimensions. And then how did we convert? You got it in linear meters, right? So what did you do? You double click on that and change the default display. Default display. Normally what we did earlier when we created dimension groups, we have this what do you call menu, and then we selected even the colors, right? We selected what you want to measure and display and all these things manually. This time everything is automatic, but sometimes you can come and change the default display. If you now, for example, columns are measured in linear meters, so that is not good enough for us. We all know the method of measurement says you have to measure in volume. You change the volume and say update, you get the volume here. It's not a big deal changing from length to volume. Right. So can I get out from this again and do another? Okay, good. Let's do it. Okay. So I can't see the last one, what you have measured. Right, if you want to add any other dimensions, if you want to add any other dimension, you go back and say, show me all objects now, right? And if you want to say, you want to measure piles also, right? You want to measure, or you want to add piles, right? So what you do is you you select the piles, show objects all, let's say pile, right? Now you have both this one and that one, right? You go back and say show all objects, and you have selected this anyway. Right now, let's say you want to select columns and piles both together, right? You select this one and say till piles, right? You have piles also. Now you can run another one, but remember this will be duplicated now, right? So the best thing is before you, right? If you want both piles and columns together, right? What you need to do is you have to delete this folder and then run another. Like if you want now, you both show only object in piles, right? And then you can create dimension group, sorry, dimension group import dimension using beam template and say, get me the selected objects and select this particular file type, and then say open. And you can see here the pile quantities, right? That is given in cubic meters automatically. So that is also possible. Separately, you can measure the piles as well. Different diameter. You can see 400 and 500 millimeter diameter. Right. And then if you want to add to this, let's say likewise previously, you want to add to this the pile caps. Okay. So you select pile caps and select only the pile caps here and both pile cap. Yeah. Right. Now you have selected the pile caps and the piles now, right? Now you create again, you import beam dimensions and say selected one. You can select this and see what happened. Now you have only the pile caps. So you see only the pile caps here.
I think there are two types pile caps, right?
Yeah, three types actually.
Feel pile caps, right?
Now there are only this pile caps.
362 previously came to you 70 something, right?
Now that was I can't remember the figure that I've got. Yeah, it is based on the selection. Yes, if you have selected all the pile caps, you will get all the quantities related to that. If I have not taken all the piles, probably by mistake here, right? I think I have selected everything here. You can see. Okay, there are few pile caps which are not being selected. You can see. Yeah, you are correct. There are some pile caps that has not been. Wait. Yeah. Some pile caps have not been selected in that first place. That's why they are not in green color. Yeah, that's why you got 72. I think earlier we have got 87 or something. Yeah, so when we select the object, you need to be careful. That's all. Now, for example, let's say, yeah, show only object structural foundation pile caps. So I've selected probably one type of pile cap here, not all of them. And let's just take this one here. I think that has everything. So you need to be careful when you select the pile caps, okay? But this is not the point. I just wanted to show you how to select one item from a 3D model and then get the quantity, that's all. I'm not going to generate the dimension groups there and then make a BOQ for each item. No, I just wanted to show you, even if you want a quantity for a particular item like pile caps or pile or maybe a slab, right? Maybe columns. So you can isolate those components, those objects from the 3D model like what I did now, and then abstract the quantities using dimension, import dimension. Because you are selecting particular objects, that's all. If you want to select only the slabs, you can do that. If you want to see the slabs, right, you select all the slabs. And now you can run this one import dimension by using BIM template and say, I need the quantity for the selected item, and you can see flows. But all flows are here. All the flows in the 3D are here. But it is in square meters now. Now, if you want to convert into cubic meter, it's a matter of double click, right? And then default display, you can change to volume. Done. Job done. 703 cubic meters. Now, even if you right click and right click on that one and say delete, sorry, not delete, object properties, you can get it, right? Object property. That's 225. Now I have selected the wrong one, probably. Okay, that one. Okay, this one. 1631 cubic meters. Let us convert this one into cubic meters. Volume, update. You get 996, right? You don't have to go there. You go to this one and okay, just right click and say object properties, or you can see from here as well, area and volume on the cage. So those properties are already given, and that is what you get here, right? So what you get in your 3D model, you get in dimension groups as well. So CostX can abstract information from this 3D model into how we want. That is what we call as quantity harvesting. We don't call it as taking off when it comes to 3D. We are just abstracting the quantities. But can you do that also? Can you show um, the slabs and then get the quantities? Now, if you are a contracting QS, sometimes this might be helpful to give some reports. Let's say you want to order material for this top slab, for example. You want to order material for the top slab, right? As a quantity survey, you will be asked to do that. So it's a matter of, right click on that and say object properties, the one way, or the other way is, of course, you can generate the dimension groups based on the 3D model, right? And then you can give the quantity in no time. It takes only few seconds, unlike in 3D, 2D measurements. 2D also very accurate, but of course, then the quantity survey, the user will have to do more work compared to 3D. I hope everyone has got it. So I go back. Now I'm going to tell you. Okay, so show all objects. Now I'm going to, okay, I'm going to delete everything, okay, what I have generated, right? I just want to show you now the bigger picture. So what I can say is, if you want to like isolate some of the items and find out the quantities, you can do that. So isolate using right click and then go to dimensions, import dimensions and say import dimension using beam template. So whatever on the screen will be here, the dimension groups. So you can take the entire substructure if you want, or maybe only the floors, or maybe only the columns. You can create dimension groups accordingly. But actually speaking, you can take all the dimension in one time. So delete all of them, okay? Now I haven't measured anything. Now we have a 3D model and you want to get all the quantities in 10 seconds. Right? You don't have to select any items or anything. No, you have a model. You have been given a Revit model, let's say, and you want to generate all the quantities in no time according to the model, okay? So quantities are always accurate as good as accurate as the model itself. If your model is a garbage, your quantity also will be unreliable. But if your model is very good, accurate model and done in a particular way, then your quantities will be very accurate. Now you see the entire model. Now you are going to generate entire dimension groups from this and produce a BOQ also. How do you do that? Now you have the 3D model. So can you follow with me? But can you follow me? Go to dimension, import dimension. You have not selected any particular component here and say import dimension using beam template and everything. Give me everything in the building. And you can see it takes time now. And you can see, okay, units have been automatically selected. Units, CostX has selected. You have the liberty to change it. Okay, fine. And it is reminding me that some of the units may not be the units that we want. For example, we don't measure slabs in square meters, correct? We measure in cubic meters. So likewise, structural area reinforcement, right? Columns in meters, foundations, structural framing, beams in linear meters, structural stiffness, okay, and then walls. You can see, you can always see what we have measured here, right? You can see this 425 here. And if you are not sure, what you do is you go to drawings and go to the transparent wireframe mode. Then you can find out. You can see these 425 walls are from this, right? Those are the walls. And these are the walls. And if you want to find out which, let's say the particular beam, okay, these are the beams. These are the beams that we have taken for this 158 meters. Okay, and then rectangular beam, you can see, yeah, it's a full of beam here, right? You can see now, they have taken the beam like this. And if you want to see one of the beam, let's say 30-meter universal beam is here, okay, somewhere here. Universal beam means it's a still beam, right? These are still beams. You have to convert into kilograms here, right? And then structural tubing, meters. Concrete rectangular beam, of course, you can see here. Concrete structural beams. So these are the beams they have taken. Now, if you want to do in cubic meters, what you do is, of course, you need to convert. And here, okay, how do you do that? You double click on that and say, give me in volume, right? Cubic meters. Now, for example, let's say this universal beam, if you know the kilograms per linear meter, then you could even convert into weight, correct? Now, if you want to make it like kilograms, right? Here default display length, you can call it weight, but the problem is you need to give a factor. You need to give a factor. Okay, what is the linear meter weight of this? Okay, so when I explain reinforcement measurement, I will explain how to convert linear meters into kilograms. Okay, one thing is you can convert through the workbook. You all know that we can use a factor and then we can convert into kilograms, any linear meters. But you don't have to do that. You can introduce certain equation, which I will explain next week. That is called extended properties. So when you know the extended properties, you can even convert into weight. I'm not going to discuss that one at the moment, right? So you can convert, like for example, round column, cubic meters, right? You can always convert into cubic meters. You have to select the appropriate unit from here. That's all. You understand? Even the flows. If you take one flow, double click. Unfortunately, you can't click everything and convert into cubic meters in one go, because those are objects one by one. You have to select volume and object. Now you can see. Right, so this is this, right, concrete with okay, this one here, and then if you take other, these are the other flows you can see. Understand? Right, and if you want to change the color even, now you can do that. You can see I've changed the colors here, and that is a slab. And if you want to see slab and the beam together, you can select. And you see how it look like. Right. Normally, when in quantity surveying, you have a question. I thought you will be asking me that question. Right. Normally, in concrete beams, if you measure concrete, the beam measured normally the bottom part of the slab, or what is projected from the bottom part of the slab. Right. If the beam is the total volume, total height, then you have to take out the depth of the slab as per the method measurement rules, right? As per principle of measurement also same. But then the answer to that is, of course, you can't do anything when you abstract the quantities from this model because it is how you have modeled the 3D model. If you have modeled your 3D model, take in the full thickness as the slab, and then underneath part is the beam, then you get quantities according to your measurement rules. If someone has designed the beam as entire, including the height of the slab, right, then your quantities will be not according to your measurement rule. Then you need to do bit of adjustment, and also you work as a team with your designers. Then you need to tell them, look, you need to model your beam, or you need to size your beam underneath the slab, right? Don't define the beam up to the top of the slab. Of course, when you do the design, you have to do that. But when you model it, you can say, show me only the bottom part of the beam so that I can extract the quantities only on that part. So it all depends on how your model has been developed. Now, in my view here, that's why I give two colors here. If you take this one here, I take a closer view. Now, what I can see here is beam they have taken as the bottom part, right? Slab is the top part. So your quantities for the beams are in line with the measurement rule. That's why I gave two colors here. You can see. So it depends on how you have modeled the building. Accordingly, you will get the quantities. But then you need to be aware of your measurement rules as well, especially this one, slab and beam. You normally measure bottom part of the beam as beams. Top part, of course, when you measure the slab, you measure over the beam as the slab. Right? I hope you know the rule that I'm talking about as a quantity survey. Okay, this is it. When you have a slab here, right? When you have a slab and you have a beam here, right? What you do is basically, you measure slab as, including the top of the beam. You measure entire thing as the slab, and you measure only this part as a beam. That is a measurement rule. So you measure this as a slab and only this part as the beam. But then you need to see your model is also in line with this, because sometimes actual beam is up to this point, correct? Your actual beam is up to this point, and your slab is actually this part. But measurement rule doesn't say that. Measurement rule says your slab has to be measured over a beam. So you need to be aware of that rule, and you need to make sure your model also reflect that. Otherwise, you need to do a bit of adjustment to the concrete, beam concrete and slab concrete. Right. So you can see now I can abstract all the dimensions without any problem in no time. If the model is good, and if the model has been developed into like LOD 300, 350, level of details 300, 350, you get all the quantities. right? You don't have to measure anything. You need to basically convert some of the quantities into your units. That's all. Right? Can you do that quickly? And I'll take this eco homes and do the same thing. Now I have to generate the BOQ also, right? I'm going to generate the BOQ from this. Right. Are we done? Can you drop a message? So if you have a properly detailed 3D model, taking quantity is nothing, right? Only this is the structural model. And if you have combined model, including architectural, structural, MEP, you name it, everything is there. So you can abstract all the dimension groups in 5 seconds, correct? All the quantities. And you can prepare a BOQ also. Right. So you have you have abstracted the dimensions of the quantities. Now what you are going to do is you have done that. So you go to workbook and say, okay, workbook, add, generate workbook from dimension groups. Generate workbook from dimension group. You do that. And you say zone 1, zone 2 all together. Yeah, that is there, selected. And it's also said include all zones. I'll say include all zones. So I'll click double click, a double arrow. But otherwise I'll take one by one. Right? You can select like access level. If you want only the access level, you can do that. For first level, you can do that. Second level, you can do that. RDS level group. I want everything, so I'll double click on the I'll click on the double arrow and say okay. You see what's happening now. Workbook name is required. I'll give you a let's say structure, right? Structural BOQ. Okay, that is the name I give. And dimension group folder, whatever they have created, all the folders and everything. But I need to give is a name. Okay, so I say okay. Now see what's happening. I didn't do anything. This is the summary page, if you can remember. When we do it manually, flows, structural area reinforcement, structural columns, structural foundation, framing, stiffness, wall, everything. So that was available in the model. So that's why these quantities have been picked up. And we go to subtotal, double click, and you see the BOQ level. If you want to see a breakdown of flows, and you see here, double click, and you see the flows. Right, you have 150 millimeter thick, 15 cubic meters, 400 millimeter thick, 1600 cubic square meters. Now you need to be careful before you generate the workbook. You need to convert all the units according to what you want. But since I have not done of some of the units, like for example, some of the unit I left it as square meters here. So that is not good, because when I created the workbook, I should have proper units here. Otherwise, I have to change here. That's not going to work out. So you convert all the units into cubic meters, and numbers are numbers, right? And then you can generate the workbook, and you get the same units as in the dimension groups here. So I'm not going to do it again. I just wanted to show you how the BOQ will be prepared automatically. Then you can do all the aesthetic, or you can abstract this information or export this one into Excel, and then you can have you can come up with a nice BOQ with proper formatting and all. Or otherwise, you can copy and paste that BOQ here, and then you can leave those quantities against those BOQ items. You can type it here. You don't have to think that you have to take this description. No, this description is given by CostX automatically. You can change it if you want. You can see, you can change. You can change. Right. So now you have create dimension groups. Now you have created, or you have generated the workbook or the BOQ as well. Now you say how quickly you can do when you have a 3D model. Right? Can you generate the BOQ or the workbook from the dimension groups that you have created? But before that, I want you to convert all these square meters of slab concrete into cubic meters. How? You double click each one. Not here. You have to be on the dimension tab here. Right. Drawing here first, and then go to dimension tab. Double click, and then change it to cubic meter. And then you generate the workbook. And then you generate the workbook. Right. Can you generate the workbook from the dimension groups that you have created? And if you want to generate an estimate, what you need to do is you have to insert the rate. You can manually insert the rate. Otherwise, you can have your rate book here, like what we did, and you can drag and drop the rates here, like what we did in the 2D. So same principle applies. Okay. Now you have a very good understanding about CostX. Right. So can we move to next exercise? All good? Tushan, are you there? Have you done? Others? Susit has done. Good. Good. I hope everyone else is following me. Yeah, Vitana, Anisha. Yeah, good, all good. Right, I'll move on now. Right, so that is how you created a dimension groups automatically, and also from the dimension groups that you have created, you can produce the BOQ or the workbook automatically. You see how fast you can do this and how easy it is when you have a 3D model. Now I go to another 3D model. Okay, go home. Right. Again, now I have so many other things here. Now, for example, you have roofs, you have furniture, you have so many things here. Right? If you want to see inside, what you can do is you click on this, right click, and say hide objects in roofs. And you can see inside now. You can see the furniture, right? You can see the furniture, you can see the building inside now because we have taken out the roof. Okay, so I'll say put it back. Now, again, what I'm trying to do is I'm not thinking about certain elements. I'm going to generate the entire dimension groups. So I'm going to generate a BOQ in no time, in other words. For that, I will delete this one, okay? Otherwise, there'll be a confusion. Because now I'm going to measure from this 3D, and that will have an impact, kind of a misconfusion with this. So I'm going to delete all the dimension groups I have created for the other model. And I select it and right click and say delete folder. So I don't have anything here. I clean. Now I have selected the other 3D. I'm going to, okay, can you do it with me now? I'm going to produce all the dimension groups in relation to this 3D and then make a BOQ. You see how long will it take? Maybe less than 1 minute. Okay. Right. How do you do that? Okay. Now I have selected okay. On my screen, you have the entire 3D. I said dimension import dimension from Vim template. And I'll select this Revit general and say open. Right. So it took about, okay. Units have been automatically selected. Fine. We know that. Now you can see you have doors. You have all the doors. You can see. Okay. You have enterage. I don't know what it is. Fascias, floors. Okay. Furniture. Right. Gutters, plumbing, roof, plumbing fixtures. You can see water tank, toilet, tub. Now, how do you want to see them? You can see them by going into drawings and say transparent mode. That's the best way to find out, right? If you want to see water heater, where is the water heater here? The building you can see, right? And then sink is here. Very nice, isn't it? Just a second. Now you can see how easy. And if you want to select, let's say, entire plumbing fixture, you can select everything, right? WCs, and because these are objects, they are not 2D drawings now anymore. These are objects. But if you want to see all furniture, you can see that as well. These are your furniture, right? You have table, coffee table, whatever. You see how difficult, sorry, how easy it is now for quizzes, right? And you can also select other, there is flows. I don't know what it means. Okay, these are the vehicles. Okay, these are the vehicles, and then if you want to see doors, interesting. Doors and curtain walls, sliding doors, and you can select one by one. You can see here, everything is here. But if you make a mistake here, not identifying a door in the model, and you don't expect it to be here as well. So it's like garbage in, garbage out, right? If you have a very high quality 3D model, you have a high quality BOQ or workbook. And if you have like shabby 3D model, of course, you can't generate a proper BOQ then. That is obvious, correct? Right, so that can you do that quickly? Take Eco Homes 3D and generate 3D model first, and then we'll generate the BOQ also. Okay. First, you generate all the dimensions, and then just click on that and see how it will look like in your. You can see even structural connections. Okay, structural framing, even topography is here. You can see the topography is also here. Walls, all the walls are given that. Okay, and you have a breakdown if you want. One by one, all wall panels are here. What else you want? And then you have the windows. Yeah, all the windows are here. Right, so you don't need to count or anything. You don't need to measure anything right now. You need to use your common sense, that's all. All the quantities are there. But then you make sure that your model or the model that you are going to get from the architects is a complete model, not half bake, half cook 3D model. As I said, garbage in, garbage out. If you have a very bad 3D model, how can you expect a good BOQ from that? Very interesting, isn't it? So this is, you don't call it as quantity taking off from 3D. It's quantity harvesting all time or abstracting quantities. Obviously, yes, because there are quantities in the 3D model. What CostX is doing is basically abstracting those quantities into the way you want or in a way that you want, and then prepare BOQ. Okay, how to prepare a BOQ? Since you have generated all the dimension groups now, you go to workbook and say, give me or generate workbook from the dimension groups. Right. So what you do is you select all of them. Here also all of them, all the quantities, not particular item, and then say Eco Home BOQ, right? Eco Home BOQ. And you say okay, and you can see what's happening behind the screen. So there's a process happening, you can see. And you can see there's a new BOQ has been created here. It doesn't come into the previous BOQ, structural BOQ. I have created a new one. And you have the doors, And if you go to this one, you have the full description of the doors. You can just price them, right? And then let's say floors, you have again, okay? If you have also finishes, you will get the same thing, same way. Plumbing, if you have plumbing fixtures, you have all the plumbing fixtures also, shower, water heaters and everything. So it's just a matter of, pricing there. So producing an estimate from this CostX is very, very easy, extremely easy. You have automatic BOQ. Then decoration you can do later. You can you can export this one into Excel, and then of course you can come up with proper description for this based on your company format, or maybe based on the measurement rules and everything. You can amend those what you call descriptions. Otherwise, this is good enough for a preparation of an estimate. You see what happens when you have this structural, okay, let us generate the dimension groups while these dimensions are there, and see what happens. Let's say we have generated these ones for the eco homes, but while this is there, there's nothing will happen when you prepare the BOQs, because BOQs will be separately stored. But here in dimensions, let's see what's going to happen. I'm going to generate again dimensions and import now dimensions from the BIM model. And I select this and see what's happening. Now you see what happens. It comes as a combination, right? You have structural framing. You also have some what you call dimension groups related to eco homes in between. So that is not advisable, because there's a mixture here. Though the BOQ is separately, got it, but here when it comes to dimension groups, it is not ideal to mix dimension groups of one item with another one. You could have done this, right? If you have created the folder before, like let's say 3D model for this and 3D model for eco house. You could have kept all the dimensions separately in separate folders. Right, so this is all about 3D modeling or 3D measurements. But I just wanted to show you one more 3D view. I can't share this 3D view, unfortunately, because this is an ongoing project. But I have got it from Muscat office. I'm sorry that I can't share it with you. Just to show the AC. I've got model for air conditioning, and it's been loaded. It's heavy actually. You can see here. But we have seen all civil works like structure, architecture, and so on, but we haven't seen MEP model here. Now you can see these are the ductwork, and let's see what happens when you generate the dimensions from this model. You can see here. So I'm going to delete all the dimension groups. Delete all the folder. I'm going to generate right. I'm going to generate. Okay, now you can see you can do the same thing if you want to see only ductwork. You can do. It's almost the same, right? When it comes to MEP model, and this is an air conditioning model here. You can see. You can see the properties, right? Object properties and all these things are still the same. But now I'm going to generate the dimension group from this 3D. So go to dimension, import dimension from dim template and select Revit general file and see what happens. So if you have a 3D model, maybe plumbing or any air conditioning or anything, you just try that out with this your educational version, okay? And try to create dimension groups and say, okay. Now you can see all air terminals, like all the louvers, duct fittings, everything is here. Long list. Right, ducts. Let's go to drawing and transparent view. You can see here. Right. All the fittings you can see. You can see all the fittings. Right. Elbow. Right. End cap. Transition. Okay, this is very good for the estimates. But in some of the cases, some of the items you may not be able to include in a BOQ because some are included in the ductwork. So that is where you need to be careful when you convert this one into a proper BOQ, right? You need to know your measurement rules, right? And then what else? Duct, okay, air terminals. These are the air terminals. You can see if you take all the terminals here, yeah, very interesting, isn't it? And this is your building. And this is the architectural building. I'll show you the architectural building. Again, I'm not able to share this. This is an ongoing project. It takes time because there are a lot of details in the 3D model. That's why it is taking a lot of time. My machine is not so powerful. Yeah, this is it. Yeah, this is the building. It's not a single building. It's a you have building here, you have building, and this is an architectural model. And you can generate the dimension groups for this architectural model also if you want. And this is the AC model of this building, the previous one that I have shown you. So you can measure the quantities in no time. It could be a high-rise building or it could be a very complicated building. If you have a proper 3D model, right, with all the details, then it's a matter of 5 minutes for all of them, including converting into your own units and then prepare the BOQ. Right. Do you have any questions from this 3D now? If I can move into reinforcement measurement now, that is balance. All good? Okay, good. So you must be very happy now, right? You don't have to do any calibration here. You don't have to do any manual, uh, what do you call, dimension groups. You don't have to create, but everything is automatic. And then you can also generate the workbook automatically. And if you want to select certain items, you can then abstract the quantities from the selected items. Or if you want to select the entire dimension groups of a particular model, then you can generate the model the BOQ and as well as the dimension groups or basically the quantity. Right. Of course, then you have to use now if you have a concrete quantity, then you have to work out how to calculate the formwork quantity. If the formwork is given in the module, which is very it is which is very unlikely, then you know how to calculate the formwork area, right? When you drag and drop from the dimension groups, you can select the wall area, for example. So those things, of course, as a quantity survey, you need to know. And that's why we learn like how many hours? About 21 hours on the 2D drawings. Because all the principles are there. I have taught you all the principles. You can apply those principles now. Now, even if you want to create a manual workbook, you can do that, okay? Let's say you have to do a manual workbook. You don't like to do a kind of, let's say, automatic. Now, let's say you have a door, right? And you go to quantity and you delete all the quantity. You can do it manual, drag and drop, like what we do. Now, for example, let's take concrete, for example. This is MEP, right? So what you need to do is basically let's say you have to drag and drop, right? And then you go to the next level. To delete this, you go to the next level and then let me check. Let's say I want to just go to this level, and this is the door, by the way. I just want to drag and drop something here. right? And it will ask you whether it is going to be count, what you need or anything else. So you can select, let's say wall area. If it is a concrete column, you can select the wall area so that you can, or let's say the pile caps wall area would be um, your formwork, isn't it? Then you can work out or you can derive the quantities from the given measurements. So I'm not going to teach you again because we have done it again previously. Right, so I'll close this. Right, so this is how it will look like. I'll take a backup of this. How to make a backup because I want to create another building called reinforcement, just for the reinforcement, okay? Or maybe we can upload reinforcement building into, okay, let me check into the previous one. So I close this, okay? Right, I'll start again. What's happening? Yeah, I'll select again Muscat Hotel. And I'm going to add a drawing. Or probably it's better to I want to show you something else. So I will create another building here. Okay. So I'll create another building called reinforcement. Right. So create a new building called reinforcement measurement. Okay. You don't need building code anything, but the project should be default because education version you have only default project. Building type you don't need to put anything and say okay here base unit. Here base unit I'll make it as feet because I just wanted to show you how you manage feet and inches. So this time I will create as feet because my drawing is in feet and inches. So you have to select this one as feet and inches and say insert. Right. So you have created a new building under default project. And I'm going to upload a drawing. I think you have got this drawing. Okay. So I'll go to drawing and say add drawing. And I go to my drawing file. In training, CostX training, and then 360, and I have a drawing folder. Where is it? Okay. Yeah, you have a folder called steel here. Under drawings and BOQ, you have a folder called steel. And in there, you have a drawing called Mount Lavinia. If you don't have, I can put into the chat box or WhatsApp group. And I'll take the model. For the reinforcement. Right. I have this here. This is what I have got. First floor slab details. First of all, just check whether you have got this drawing. If not, can I drop this one into your WhatsApp group? Have you got this drawing? So I'm just posting it in the WhatsApp group. Right, can you upload this drawing? Right, when you see this drawing, you can see, I just open this one. Okay, I can't open, unfortunately. I don't have AutoCAD in my laptop. Right, I'll open it in CostX just to show you. Okay, and it is given in inches and feet. So that's why I have taken, I have selected feet when I create the new building. So I have created a new building called reinforcement measurement within the project, default project. And when I upload this, right, I did a mistake. When I upload this, I need to change this. And it is in millimeter here. I need to change this to inches. Because earlier we have selected millimeter here when you introduce the drawing and meters when we introduce the project. Here we have introduced feet when we introduce the project, and when we introduce the drawing, then we have to select inches. Then only it will work like feet and inches and meters and millimeters. And I'll say OK. Now you see, if you want to measure something, okay, we need to now do the calibration, of course. So, okay, let's introduce this first and then we do a calibration quickly. Meantime, I'll grab a glass of water. Okay. Now we have uploaded the drawing, and in doing so, we have defined feet and inches as units. Earlier it was meter and millimeter. Now, knowing this is marked in inches and feet, so we have to be careful when we first introduce the drawing and when we first create the project itself or the building. So we can work in feet and inches also if you want. That's why. Now let us do a calibration quickly. The measurements. Okay, here. X-axis calibration, like what we do normally. X-axis calibration, right? And here to here. Okay. I can't see the figure. Okay. It gives in inches. Right, how many inches? 12 into 17 plus 3, correct? So 17 into 12 plus 3. So it's 207 inches, correct? 207 exactly. But if you want, you can just make it as 207 inches. Yeah, done. But normally what happens, AutoCAD is 1-to-1. You don't have to even think about it. Drawing is already calibrated. We reset the calibration before. Okay, so we have selected both sides. So we will do a quick measurement and see whether, yeah, it gives like 10 feet and 2 inches, 23 out of 32. I think there's a small calibration error, but we did. We all know 1 inch is 25.3 millimeters. Right, if you do reset calibration, use reset calibration, I'll do a calibration again here. So the big mistake would be, right, let's just measure this one, measure distance from here to there. Exactly. So that is a perfect calibration, 17.3. So that's correct. Why? Because AutoCAD, it is always 1-to-1. We have to just double check the dimensions, right? So let us calibrate anyway. Calibrate x-axis, reset calibration, calibrate x-axis. You have to pick the right point, and then here, yeah. So I'll take as it is, and I'll apply the factor to y-axis also. So I'll take this as correct and say okay. Right, can you do that? And then you double check one of the measurement here from here to here. It should be correct. I think the starting point is wrong. It's also correct. So there's a slight mismatch. Don't worry. It has to be 17 exactly. But I'm getting like 16 and 11 and a half. Okay, I'll take it as correct. There's a small issue with the drawing. So this dimension is correct, this dimension is not correct. That cannot be the case, correct? If you measure this exactly from here to there, and you get okay, I'm getting 17.3 and a half. That means again my calibration is not correct. I'll reset calibration. Anyway, we are not going to use feet and inches much unless you are in Sri Lanka. Sometimes some architects still draw drawings in feet and inches in Sri Lanka, but I haven't seen the Gulf. 17.3, I'll make it as 17 into 12. Seventeen into 12 plus 3. 207. Anyway, there's a small mismatch, that's all. I'll make it as that way. And I'll get a small mismatch. It's okay. Right? If I measure this one now, I'm going to get measure distance from it's like 1611. 1611. Okay, instead of 17. It's okay. I'll proceed with this now. Right, so we have calibrated now. Okay, it's 1 to 1. Now we are going to measure reinforcement. Okay, how do we read the reinforcement? Let's take one panel here. If you take one panel and if you read this reinforcement here, it says T10. That means tall steel, 10 millimeter diameter, right? 9-inch and bottom 2. So it's one of the bottom net, right? And 9 space interval. So that if you take this dot here, you can see this particular reinforcement, you can see it's a U-shaped reinforcement here, is to be spreaded from this point to this point. That's what it says. And that is one of the bottom net. Okay, so this goes and then this comes up and then goes on top of that. So it's like this side is a U channel, U shape, but this shorter part is on the top. I hope you can read this. And this bar is to be spreaded from this arrow to this arrow. That is a span, we call it. And that is one of the bar. And the second bar is, you can see there's a dot here. And that dot is this one, straight one. This is the straight one. And that has to be spreaded from this point to this point. and at the space of 8 inches now, and it is called bottom one. So this is one of the, so you can see the two bottom reinforcement, and bottom you have a mesh. But one of the reinforcement will come up and it comes to top part of the beam as well. It all depends on how you design your slab, not you, I mean the structural engineer. Right? I'll take only one panel and I will show you how to do the reinforcement calculation. Right? Here also same. Right? You have this straight one from here to here. That's all. So you have only bottom reinforcement in this case. But I would say, since I have to cover this one, I will teach you. But I will not use CostX to measure reinforcement unless you have ratios. I have discussed the ratios, how to apply the ratios at the very beginning, right? But now we are measuring actual reinforcement, but I don't think CostX is the best software to measure reinforcement. Because there are specialized software to measure reinforcement, but I will show you how to do that, okay? Right, so I'm going to measure these two reinforcement and convert into kilograms. Right. So can you now calibrate and be ready? You have to, now we are back to 2D, okay? We are back to 2D. So we have to create dimension groups, so obviously. Right, so we'll create a dimension group now. Right, so we'll create a dimension group, add dimension group, and say T10, okay? T10, we are going to measure. Folder, we call it as reinforcement. Right, folder called reinforcement. We are going to measure T10, toe steel 10 millimeter dia. Measurement type, length, correct? Measurement type, length. Default display, now not length, I want in weight. And unit of measurement, I want in, let's say, kilograms. Earlier, we haven't selected unit of weight. This is the first time we are going to use. Right? Now, you must be wondering how, when I measure length, how does it give in weight unless we created relationship between length and weight? Because CostX doesn't know the weight I have to introduce. So how do you do that? That is where you have to go to this measured dimensions. That is how you create weight or length into weight, okay? You go to this, you convert this one into, you are going to convert this one into kilograms, but you measure the length. You have to go to this tab. We have not used this before. Go to measured dimensions. And that is what we call as extended dimensions, okay? Here, right, here you have weight. You can see here weight. You have to click on this weight. You have three dots, you can see. I get a noise from side. coming back. Okay, I lost my concentration. Now I'm going to create a dimension group. So dimension group for reinforcement and dimension group, and I'll say T10. I'm going to measure T10 bar. Folder, I will say reinforcement, and I'm going to measure in linear meters a length. Okay, and default display I need in weight, because reinforcement will have to be measured in kilograms or tons. We can convert into tons if you measure in kilograms, right? And then weight unit of measurement I need in kilograms. We have to select that, because now you have to establish the relationship between length and the weight. How do you do that? We have to go to this tab, measured dimension, and you can see the weight here, and there are 3 dots here. There are 3 dots here. Okay, can you do that up to that point? Can you do up to this point first? And I'll let you know the balance. So having calibrated the drawing, you have to introduce dimension group called reinforcement. As I said, CostX is not the best software to measure reinforcement, by the way. There are specialized software that can be used to measure reinforcements. Some structural analysis software like SAP 2000, it will give you even the reinforcement quantities from the model itself. We are talking about 2D now. This is a 2D drawing. So we have to establish the length, the relationship between length and the weight. How do you do that? You go to now measured dimension, and you can see here weight, and you have a three dots here. You click on these 3 dots, and it will allow you to introduce equations. It will allow you to introduce equation. Now, for example, you double click on weight, double click, okay, and it will appear here. You can see here. When you double click on it, will appear here. I'll just delete it. I'm going to introduce an equation. How? Right, you are here, and you come to this measured dimension tab, and go to weight and click on these 3 dots. Double click or click, and now you have to introduce weight. Here you can see the weight. You double click, and it appears here. And then weight multiplied by your linear feet weight now. Okay, linear meter weight, if you go to Google, linear meter weight is 0.617, but now we are going to measure in feet, correct? So the multiplication factor is different. So 0.617 is for meter divided by 3.3. You get kilograms per feet, and if you go to internet, you will find it anyway. Right, so 0.1, sorry, you have to multiply it by 0.1869. So this is the kilograms per linear feet of T10. T10 linear meter linear meter weight of T10 is 0.617. If you go to Google, you will find out. That is 0.617. That is per meter, right? Kg per meter. So I just converted into kg per feet. So how do you do that? This divided by 3.3 approximately, because there are 3.3 feet in 1 meter. So this will become feet per, sorry, the other way, kilograms per feet. So I'm using this one for this equation. How much? Like 18697. 18697. Okay, good. Now I close this. Now you can see that equation has come into here. This equation has come in here. So with the equation that I have introduced. Now if you go back now, it goes as kilograms. Now I have defined this weight as weight into 0.187 because that is the feet, linear meter feet weight, and job done. Okay, so I'll say insert. Yeah, sorry, there's a small error here. Weight is not weight into this one, weight is length into this one, right? You double click on this. This is not weight, mistake. It has to be length into that, correct? Length. Yeah, here, double click. Yeah, it has to be length into this. Then only it will become weight. So I'll close this, and now it is correct. Length into linear meter weight or linear feet weight now give you the kilograms and say insert. Now you can see, sorry, measurement is in kilograms and we are measuring T10. Okay, good. Now we are ready to go. How do you do that? Okay, can you come to that level? Now, when you measure reinforcement, you have to use a special bar here. You can see here rebar. All these days we didn't use this. Okay, rebar. Now, when you now we have calibrated, we have created a dimension group. Now we are ready to measure the reinforcement. You have to click now this. Now CostX knows that you are going to measure reinforcement. Okay, right? You click on that. Now you are going to measure this bar now. Okay, you are going to measure this bar. So what you need is basically length of one bar and then the span. From the span, it will calculate how many number of bars required. And if you multiply by the length of one bar or weight of one bar, you get the complete kilograms of the bar, bottom two. That's what we are going to do. So we are going to measure the length of one bar from the drawing and also how many bars, because we know the spacing and you know how many bars that you need to spread across or from here to here. Is that clear? Right, so that is what I'm going to do, right? So I have to select the point mode now, right? And okay, now I'm here and I'm on rebar now. I'm going to measure, maybe let's take the easy one, this one, okay? Right, so I'll take the point mode and I'm on T2. I'll measure the bar, length of the bar from here to here. Now you can see the color has been changed. Right, now enter. Okay, so that is the length of the bar. Okay, now I have to give the spacing. I should get a dialog box. I'll do it again. Right. So I've created this. I'm going to measure this bar now because I have to press this one first, right? And I have to select the point mode. Now I'm in the rebar mode here. So I'm going to measure this bar, length of the bar. Okay. And then enter. What happens? Okay, now I have to select the do it again. It's correct. And I have to enter. Then I have to give the span. Okay, it works like that. Okay, let me put that way. I have not done much reinforcement measurement from this, to be honest. Okay, let me rewind. Now, after the calibration, you have to press the bar, okay, rebar button, because you are on the rebar mode now. And then you have to select the point mode. Now you are going to measure the rebar first. The length of the bar is from this point to this point. You can see the bar is turning into like a dotted line, right? And that is the bar, and that bar is spreaded across from here to here. So you have to select at the same time here to here, and then enter. You understand? You have to do both together. And you have to give the spacing. So what is the spacing? The spacing was 10 inch, isn't it? Let me check. This bar, the spacing 8 inch. Okay, 8 inch. Spacing is 8 inch. Okay. Now when you click on this, you don't have any extra bar distance or anything. You just click on that, then you can see number of bars. So total length, if you take the length and divide by 8 inches, you get 17 bars and plus 1 bar for the edges. So you get 18 bars and you say update. That means you have measured this bar and you can see 39 kilograms. Okay, can you do that first? I'm going to do it again. Can I do it again? I'm going to delete this, what I did. Delete dimension. Okay. Right, I'm going to measure this bar. Okay, this bar. I'm going to measure this bar. How do you do that? You have to first press the rebar button. Now you are in the rebar mode. And also you have to press the point mode. That means you get this kind of thing and then you measure the length of the bar first. Right? And then you can enter, that's okay. But you can also measure the spacing. This bar should be spread from here to here. And then enter. And you get this kind of a dialog box. And there you give the spacing. Spacing is 8 inches, correct? Because this is bottom one, 8 inches. So you just click on this. Sorry, you have to give the 8 inch. Because this is in inches, you can see 8 inch. And then when you click on this, you get the number of bars, 17, and update. And accordingly, you will get 37 kilograms for the bottom one. Now we are going to measure this one, the other bar, right? This bar, this one. So how do you do that? Okay, so again, I'm on the same thing and rebar already done. I'll measure this one and this one. And if you want to add, now you can't just measure like this because this is not exactly the dimension, because you need to come out. It has to be like if I do this one, right? The bar should be right. This is your bottom bar and it comes up and then it goes. If I do a section like this and your slab is like this, correct? Your slab is like this. Yeah. And this is the bottom bar and it comes up and it goes a certain distance. So this distance, the vertical part is of course 25. Let's say you have to reduce the cover. Let's say this is 200 millimeter slab, okay, or 150 millimeter slab, and then you have to deduct 25 and 25. That means 150 minus 25, 25, 50. 100 millimeter is the vertical part here. 100 is the vertical part. So you have to add that 100, right? 100 and then the length of this. You can add extra if you want, you can add that. So what I do is I'll take, for the moment, I'll take this curvature here, right? Control. Can you remember? You can put control and then you can just measure. Now it will be like one bar. Now that bar is spreaded from that where? From here to here, right? From here to here. And you just enter now. And now you can see spacing. Spacing of that is 10, right? Or 9 inches. So I'll put 9 inches here. So when I click on this, you get the numbers. And extra distance per bar, if you want, you can add that extra 100 millimeter without measuring this curvature. You can add extra distance for the entire thing. For example, you measure only that part and the top part you can measure as a, or you can add that as a extra distance. So I'll do that way. So I'll not do this way. Okay, let's get the kilograms in this way and say update. Okay, now you get 79 kilograms. Okay, right. Now I am not going to do that way. I'm going to remove this 42. Remember this. This was 42, okay? So delete dimension. I'm going to do it again. The second bar, different way. So I'm going to measure the distance of one bar here from here to here. That's all. And my span is from here to here for that. And then enter. You don't enter at the first time, okay? You measure the bar and you measure the span, and then only you press the enter. And spacing is now 9. So you get the number of distances 19, and then extra distance you can calculate like this. Normally this one is about 600, okay? That is given in the drawing normally. You can measure even if you want. That is 600, and plus this 100 is 700. So you can add that 700 to here. It's not 700 now because it is in inches. So 700 divided by 25 inches. 700 divided by 25 inches, 28 inches. So I'll add 28 inches here and say update. Now you get 40, instead of 45, I think you get now 42, and which is accurate. Right, so that's how you do the calculation for the reinforcement, and this is you also can understand now. This is not easy way to do that, right? To measure reinforcement that way. If you have all the bars drawn, then you can do that. Otherwise, it's very, very difficult. Otherwise, you have to use your ratios. You can introduce the ratios. Can you remember when we do the ratios? Right, you can introduce ratios. Not here. When you introduce the workbook, you can introduce the ratios here, and then you can apply cubic meter, sorry, kg per cubic meter of concrete. That's what we did when we measure the reinforcement of substructure, correct? Now this is a detailed measurement of reinforcement. So you first measure the bar, that dotted line is the bar, and also measure the span, and then enter. Then you go into that particular dialog box. There you need to define the spacing and any extra distance you can specify there. So everything will be converted into kilograms because we have defined the kilograms earlier. So that's all as far as reinforcement are concerned. If you want to measure this one, okay, you can measure this one. So please do with me. So let us measure this bar, okay? So from here to here, right? You can see the dotted line, and then that bar is to be spreaded from here to here, and then enter. Right? What is the spacing? T10 9 inches. So give the spacing 9 inches here, and you get the number of distance here automatic, and you don't have any extra bar to update. You have measured that as well. So when you measure the reinforcement, the area will be highlighted this way. And you can measure even this one small one here. Right. So you can just continue to measure. It's not a big deal. You measure this one. By the way, it is T10, right? Yeah. So this one here to here. Okay. Let's start from here to here, right? And then here to here. That's the span. Right. And then enter. And spacing is 8. and you get the number of bars automatically calculated and say update. That is also done. And you can measure the other one. Right, you measure this one and the spacing is from here to there. And then enter. And what is the spacing? Let's see the spacing, 8 inches again. Enter, 8 inches, and you get the number of bars and update. That's it. So we have measured everything in that particular reinforcement, in that panel, I should say. So it's not easy to measure, like when you have like top measurement, right? And also if the reinforcement are not drawn properly, and sometimes you can give only 1 bar. Sometimes it gets difficult. But I'm not going to spend too much on this reinforcement measurement because I don't recommend CostX to be used for the reinforcement measurement. So the best is, of course, you can do sample calculation and find out kilograms per cubic meter, and you can apply that ratio in your BOQ preparation. Anyway, that's how we do commercially, right? We don't measure all the reinforcement anyway. We measure one column or maybe few foundations and we get the average, and then we apply that average ratio to the entire foundation or slab or all the other elements. All right, guys. So this is what we call as reinforcement measurement. What we have learned just now is an extended properties. We have used a calculation here to introduce the weight. Weight is length into kilograms per feet in this case. Now, if you are using a drawing with SI units, then this has to be length into linear meter weight. And that goes to, and this calculation goes to this kilograms. So that means you can introduce some equation, right? That's what we are going to look at the next day. So next day would be the final day. We have done 3D measurement, we have done 2D measurements, almost everything now. And I want to show you how we can assign equations. And we have, this is just a beginning. This is how we assign the equation. We click on this 3 dots and it goes to a kind of a Visual Basic interface, right? I'm not saying this is Visual Basic or anything. It goes to an interface where you can introduce certain equations. And then you can apply those equations into your properties here. You can introduce not only those 4, you can introduce new. If you want to introduce surface area, you can introduce here surface area. I'll explain you next week. Do you have any questions on today's work? I want you to practice. Okay, take a drawing. If you have a drawing in your office, I'm sure in matrix unit, but reinforcement one. Right, matrix unit with reinforcement. So you don't have to do all these things. You don't have to introduce your feet and inches when you introduce the drawing. Right, you can just enter. Okay, you can just create a building called reinforcement measurement. There, the method of the measurement would be millimeters. And when you introduce the drawing, you have to select the measurement as millimeters. So you can work with meters and millimeters. And spacing also would be like meters and millimeters, obviously. And then you have to click the rebar and the point mode. And firstly, you measure the bar length of the bar, and then you measure the span. And then click, you have to define the spacing, and you will get the kilogram. Of course, you need to, before that, you need to introduce the weight as, sorry, the default display as weight. And then you have to establish the relationship between weight and the length by giving or by introducing an equation. So that is the only thing in the reinforcement. All right, guys, are we okay? Everyone has done this first. Okay, let me see whether you have completed this. Can you drop a small message if you have done the reinforcement part? Then we can conclude the session. All good. Tusit is done, right? Tushan has done. How about others? Raghu, Kadir, Itana. Just let me know if you have done the reinforcement part. All right, guys, then I'll call it a day. And next week would be the final session. So when we meet, we will see how we can introduce some equations so that we can measure some of the other parameters, not only these parameters that we normally find. Now, when you create a dimension group, these are the parameters that you normally automatically come across, like count, length, area, wall area, volume, weight. Now you have just learned how to apply the weight. You have to give a dimension, you have to give a relationship to this weight here, right, through a small equation. So likewise, you can give the surface area when you measure the ductwork, for example, right? You can give give an equation so that you will see the surface area here, right? Even the formwork area you can introduce here as a parameter. So there are so many things you can do with this part actually, and this is called extended properties, right? Now you can see this area is length into width. All are automatically by default. These are the area. These are the equations. Wall area, length into height, right? If you have a length, a linear meter weight, volume, area into height, weight, length into, we have just given an equation. So likewise, you can introduce certain parameters here, and those parameters will appear here. You understand? So that is kind of a top end of the CostX. Right, so I'll stop here and I'll see you next week at the same time, right? So please practice during the week so that we can wind up the session, wind up the course next week, okay? Good. Thank you very much and good night to all of you.
Right.